Okay, so we're talking over transformations. And you've got these equations, and you take a mother function, so to speak, or a parent function, and you do a whole bunch of stuff to it. You should know all the things that it does. All right, so the negatives, let's just change this to, I had it written on the wall over there, but I'll just make another one. Let's say I had something like this. What does that negative do? Flips it up, down. Okay. Yeah, I hope you know the official way to say that. Reflected R of x. Okay. How about this part right here? I'm hearing lots of different things. Raise your hand if you think it makes it taller. You are correct. And it's 3 times taller. How about this part right here? Right 5. How about this one right here? All right, good. And the stuff on the inside is kind of like in prison on the inside. You just can't trust it, right? How about the outside? You can trust it. All right, so when I say can't trust it, why can't I trust that minus 5? Because it seems like it should move which way? Left. On a graph, I mean, you'd think negative should move left, but in fact, it actually moves to the right 5. It does the opposite of what you'd expect. What's the official name with that? Starts with a C. Doing the opposite of what you'd expect. Counterintuitive. Very good. All right, good. So this is the part where we see if we can make the Centio, which in this room is kind of sketchy, work. And I'm going to ask, one of those 4 right there is the right answer. Don't say it, please. I'm going to add an instant question. And I want you to put it on this page always. And this is A, and this is B. Oh, must start the class. Okay, hold on. Still let me start up. Anonymous mode will be fine for this one. Okay. C and D. Okay, I'm just kind of judging by the fact nobody's answered yet, but then again, it's kind of a tricky question, so. Not working? So it's not working. Oh. All right, hold on. Stop this question. This question has never been started. Oh, that's nice. All right. Seems like it has to me. I want to start this question now. Now, is it letting you in? Okay, give it a second. Okay. We thought we had this fixed on, didn't we try this Friday or Thursday? All right. Well, thank you for trying. I still want you to answer this question. Would you put it on your piece of paper? And I want you to circle it so that I can see it quick, so I can get a feeling for how many of you think it's A, B, C, or D. All right. Thank you. I can tell you this, I'm getting different answers. There's 2 that seem to be coming to the top the most. Of course, now it's making some of you go back and change your mind because you realize, ooh, maybe I'm wrong. All right. I can tell you this. It's not A. Can you give me a reason it's not A? Give me one part of that just can't be right. Yes, sir. The 4 is on the inside. That's correct. It's on the inside, and therefore that should be a horizontal type thing. And it says vertical, so you're right. Can't be A. Who else wants to eliminate one? I know it can't be this because, yes. The 4 is on the inside again on C. Very good. This is kind of what you would do in a big multiple choice tests like the SAT or the ACT or maybe even the MCA is you might want to narrow it down. And now I got what's my percent chance of getting it right now? I got a 50-50. And now if you look at it, a lot of times they will do this. They'll give you an answer that looks like it has potential that's at B because you see that first. But then there's an even better answer down here. Raise your hand if you had D for your answer. Okay. Some of you got caught. And why? Because look at the only difference. What's the only difference? Yeah, and I had to mark that wrong on a quiz a bazillion times. There's got to be parentheses right there. All right, so B is out, and it was D. Okay, so there's a little review. That's about as hard as they get for that type of a question. Okay, some of them are graphing, where you have to look at the graph. But we're going to study more reviewing for the test tomorrow, and then the test is actually on Wednesday. So we'll review tomorrow, test Wednesday. It's on this stuff. We've already had the quiz on it, so you know what that part was like. So, all right. As These Blues by American artist Faith Ringgold shows 25 stenciled images of blues artist Bessie Smith. Was it translated or reflected to make each image? So did they do a reflection or a translation? What do you think? Because why? So you're saying it's just been moved around, and that would be a translation as opposed to a reflection. All right. An up-down reflection would mean he'd be upside down, right? That'd be pretty obvious. How about a left-right reflection? Is that possible? What do you think?
It is, but there are only 20 faces.
All right. Oh, you're thinking like the whole page had to be reflected or whatever. I think they just mean that each individual face, is it just a reflection like right here, like this face to this face, like that kind of reflection? Could it be?
No.
Because why? Okay. Ooh, I like it. See that little little thing on the eyebrow right there sticking up? You see how it's still on the left eye sticking up? It's hard to see, but maybe it's easier to see here. Like he's got a little thing sticking up his eyebrow there, and it's still on the left eye. If it had been a reflection, it would have changed over and been on the right eye. All right, that is a technique you can use. You can reflect pictures, and I've seen that before, where people want to like make something look better in the context that it's in. Like, let's say you've got a picture of the President of the United States, and he's reaching out his right hand to shake somebody else's hand. But then you really want the president to be on this side over here, and all you have to do is do a reflection, and you can do this with Photoshop. I know you know that. You can just take the whole picture and flip it, and it still looks a lot the same. It's just now all of a sudden it looks like he's holding his left hand out instead of his right hand out. And so you can do little tricks like that with photo editing nowadays. Pretty cool. All right, so back to this thing. Yeah, it was a translation. It was just moving them. All right, yes, sir. Very nice. Okay, cool. I did not write the text for this, so I will not take full responsibility, but I will get it fixed. Thank you. You're right. All right, so it's 2, 3, 4, 5 times 1, 2, 3, 4 is 20. Yeah, can't argue with you there. Okay, good job. We were just looking for some real world examples. In the real world, where do you see functions? You see one on that bridge? The cables. They're making a what? A parabola. All right, very good. And you know the base function for that is y equals x squared. Do you think that's a perfect y equals x squared? Probably not. It's probably been stretched left, right, or up, down. Yes? Ooh, I like it. Very good. Okay. Here's another one where you got people diving, and you look at the graph of it, also looks like a parabola. And now this is talking about their center of gravity, because of course the divers do all kinds of crazy things as they're, flipping and stuff on the way down into the pool. But they don't follow a nice straight line usually, but their center of gravity would. All right. I'm going to be Here's a big old word problem. And what do you think the most important part of it is? The words are important, yes, but you got it. Almost always in word problems, they're going to give you a formula. And if they don't give you a formula, you have to write a formula. You have to write out an equation. So that's why I said at the beginning that we're going to talk about how to solve these problems with five main things you got to do to solve a problem like this. But there's two main kinds of problems. One is where they give you the equation, and the other is where you got to write it. All right, here is a real-world problem. It is actually a problem that you're going to be doing on your homework in a few minutes. And I want you to just read it for a second. Oh, I get attendance. Okay. I know a policeman who handles these situations. I play cards with him at one of my neighbor's houses, and he actually does this, and I've talked to him about it. He'll analyze crime scenes. Usually it's accident scenes. He works for the State Patrol, and so a lot of times they will look at the skid marks, and they can learn a lot from the skid marks. They can see probably at the moment the skid marks start, what do you know about the person in the car? They're freaking out. Good. They know they're applying the brakes is the official thing, but they have realized, oh my gosh, I'm about to hit somebody, right? So as soon as the skid marks start, that tells you something. Next thing, the skid marks are going to be a certain length, right? What do really long skid marks tell you? They're probably going fast because it took them a long time to stop, right? Now, wouldn't it also seem logical that the surface that they're stopping on would make a difference in how long those skid marks are? In other words, if it's kind of a slippery surface, wouldn't they slide a long time? And if it's a really tacky, really grippy kind of surface with lots of little rocks in it, for instance, well, little rocks that roll wouldn't be good, but like the kind that, like a really rough surface would stick really good. Your tires get good grip. That would obviously make you slow down at a different speed. That's what they're trying to handle with this drag factor. All right, and looking over this problem, I don't like it for a few reasons. One thing is I don't like the variables that they have. Here's why. When they talk about speed, wouldn't that seem logical that that would go under S? And it is under S. That works. Okay? But when they talk about drag, wouldn't that seem logical that that would be under D? But it's not. Okay? The drag factor, if you look, D is the average length of the skid marks in feet. Okay, so D is the skid marks. And F is a constant called the drag factor. Well, I guess they have F for factor, but so if you have the drag factor, that has to go in under F. And the length of the skid marks, skid S, seems like it should go under S, but it's, well, anyway. You just have to read it carefully, and then it's really not that bad. All right, so I've got three things. I got speed is related to the drag factor and the distance that they actually skidded, okay, the skid mark lengths. All right, and on this problem, they tell you something important at the end here. The drag factor is 0.07. So couldn't we put that in somewhere? Where? The F is. All right, so that's all they're asking on A. Go ahead and write me the equation with the drag factor in there. I want to bring up something that's kind of appropriate. You guys are going to be at the age where you're either starting to practice drive soon. Any of you guys practice driving already? A few of you are. Cool. And within the next year, most of you will start practice driving or get your license. And one of the things that is killing your generation and never killed mine, what do you think? Texting. Because my generation didn't even have cell phones, for Pete's sakes. Okay, but cell phones even aren't as bad. Being on the telephone isn't as bad as texting. It's the worst. Why? You have to look at the screen, right? If you have the phone up to your ear, you can still be looking forward, right? But if you're looking at the screen, and especially if you're trying to find keys to type out something, you are hugely distracted. And all it takes is to be looking down for a second, and the little kid runs in front of you, and you mow them down, and you will never be the same for the rest of your life. And obviously, that little kid won't either. So, gotta stay off the texting. I made my kids promise that that their phone will be off when they are in the car, because it's just too tempting. When that text comes in, you want to know, ooh, maybe this will change where I'm driving. You know what I mean? Like maybe I should go to a different friend's house or whatever. So you'll be so tempted to look at the text. Just don't do it. All right. We might end up one of these crime scenes that they're trying to figure out. Oh, that's when she looked up from her text and realized she was about to slam into the tree, and that's when they applied the brakes. And okay, so I just don't want that to be you. All right. Sketch a graph of this function. Well, how am I supposed to graph something with an S and a D in it? Well, you can't. But you can graph something with an X and a Y in it. And what should I replace with the Y here? The S. Very good. And the D would become a X, and then all you'd have to do is type it in the calculator and it would be done. Don't bother right now because you're going to do it later on your homework. All right. So here, the average length of the skid marks is 60. Wait a minute. Average length? How could there be more than one skid mark? 2 tires, right? Unless it's a motorcycle. Well, even on a motorcycle, you got 2 tires. I wonder if they factor that in. Well, anyway, if you're measuring the length of the 2 back tire skid marks, could one of them be longer than the other? Yeah, and apparently you need to average all of those skid marks to get an accurate reading. All right, if the length of the skid marks is 60 feet, and estimate the initial speed of the car when the brakes were applied. You're going to be doing that today. You'll be able to tell from how long the skid marks are how fast the car was going, and that's kind of cool. It takes a long time to stop. How long it takes a train to stop? About a mile. So if they see something up ahead on the tracks, if they can see that far, that means they're going to hit it. They cannot stop in time. So people that try to, play chicken with the train, the train can't stop. It's not like he can stop if he wants to. Even if he applies full brakes, it's going to take him a mile to stop. Yes. Yes. That was a good movie, wasn't it? All right. On that note, there's another movie. Unfortunately, people at home aren't going to be able to see it. Okay, so here are the 5 steps to transform any word problem into something you can actually solve. First step, draw a little picture. Do you always have to draw a picture? No. But there are some problems that are particularly well suited to pictures, and it helps a lot to draw a picture of the situation. I'll give you an example. In pre-calc, the class you're going to take next year, a lot of times we'll have a problem that's like this, and it'll be like it's x and it's 5 times as long as it is wide. You put 5x, and then you tell them the area, and the area is like 100. So then they can say that area is length times width, and then they can put in 100 for area is length is 5x times width is x. Here's an example of how once you got the picture, it's a lot easier to figure out what's the length, what's the width, instead of trying to do it all in your head. And at the end, you'd solve this down and get x is, let's say, the square root of 20, whatever that is. It's like 4 point something. Let's say it's 4.5. Okay? All right, so you draw the picture. The next step is, what did you see me do next when I solved my little pre-calc problem that I'll have to do next year? Write the equation. Next step, after you write the equation, you take the info and put your info into your equation. Put info into equation. I've done all that. And then what did I do next after that? I solved it. And there's a very important fifth step that I haven't done yet. Yes, sir. Put. I'm gonna say it a little different, but you said the right basic thing. Check. Answer. Context. Here's my point. On that problem, kids will solve it all the time and they'll have the answer of 4.5 and they get it wrong. Why? Because the question we ask is, what is the perimeter of the rectangle? Isn't that nasty? You go through all that work, you set it up right, you get the answer of 4.5, and that's not what they want. They want, if this is 4.5, then how long would that be? 5 times 4.5. And what would the perimeter be? This plus this side plus this side. That's how you do a perimeter. And if you don't check the context, you might end up giving an answer that's the side when they didn't want the side. They wanted all the sides added up. Get what I'm saying? So when you get an answer, make sure that it makes sense in the context of the question. All right. Jimmy John's. Guys like Jimmy John's? I checked how much are they paying at Jimmy John's nowadays? Because my son was interested. He loves Jimmy John's, and so he was thinking it'd be a fun place to work because he likes to eat there, and he thinks it's a kind of a fun atmosphere. And so I checked, and it's $7.25 per hour is what they pay to work there if you get a job there. And by the way, they are looking for people in Wayzata. But anyway, would you please right now write f of x equals, write me a equation that you could write for this job. I give you a hint to start with f of x. 7.25. Yep. I hope you didn't just write 7.25. Yes. Now this could be h for hours, or it could be x if you just want to do a normal function like we usually use x, but it could have been h for hours. Do you get how you make 7.25 and you have to times it by how many hours you make? All right, good. What happens if they're really desperate for an employee and they're willing to pay a $50 bonus to the person on the first day that they start? Then what would I put? Plus 50. Why wouldn't that 50 have an x by it? Because it's not for each hour, yeah. All right. Write me an equation for this job. They normally pay 7.25, but because you're working on a week, it's not weekends, they usually don't pay extra, but let's say on Christmas Day, they're going to pay double time. Would you agree it still sort of needs a 7.25x? But how do I do double time? Yes? Yeah. Twice what you would normally make. That's what double time means. How about this? I know you're going to see this kind of thing on the MCA test. They like to throw in this one. Time and a half. 1.5. Or 1.5. I'll say 1.5. Times what you would normally make. Okay? Why do employers do that? Because they have a hard time finding kids who are willing to work on Christmas Day. You know what I mean? So they have to pay them extra. All right. So here's our 5 steps in solving a problem. And here is a typical equation that Einstein would have been working on. Remember how I was saying a lot of times you just have to take the equation they give you and plug in the numbers? Do you guys know, I just thought one of the most famous equations of all time that you should at least know what they stand for. You might have seen me erasing them. Do you know what E stands for? Energy. Some of you just saw that. Yes, you're right. And it might be wrong because the latest news is that, tell them. Yeah, they may have found something that travels faster than the speed of light. And Einstein's whole theory was based on the fact that the speed of light was the fastest thing that there was. And now they have measured these things that can go faster than the speed of light. They did it, actually they did it like 1,000 times and kept all the data because they were like, the scientists were so freaked out and they didn't want to come public with this until They were sure that there was something wrong. And then they released the data out to the world and said, show us where we're wrong. It seems like these particles are traveling faster than the speed of light. Yes. It would have all kinds of implications. Yes, that would possibly make the situation where you could have time travel. Yes. All right. Energy equals, do you know what the M stands for? Mass times, do you know what? Speed of light squared. Very good. And that's also known as acceleration. And the basics of this have to do with the mass makes a big difference in how much energy something has. All right? I'm still recording right now. If you look right here, you can see the little... Okay. Nope. It's okay. It's recording. All right, so moving on. If I took a fluff ball off of my rail here, you see the little fluff ball at the end of my thumb there? Okay. And I take that fluff ball and I wind up and I throw it as fast as I can. Ah! How come it didn't hurt him? Yeah, almost no mass. Can you imagine if I threw something that hard, it was like a baseball? How bad that would hurt? Or a bowling ball? Okay, or yeah, a giant anchor from a boat. I mean, as the mass gets bigger and bigger, you can imagine the energy will get bigger and bigger, and that's what this equation is trying to take into account. All right, so there's two main kinds of equations or problems that you'll run into. One's where you have to write the equations, like we were doing for the hours and the time at Jimmy John's. Or there's the other kind where they just give you the equation and you just got to plug in the numbers to figure things out. Do you feel like you understand what you're supposed to learn for today? Okay, good. Now, I'm going to give you a worksheet, but while you're working on that worksheet, I'm going to try to get in those two homework assignments through the wonders of the iPad. I'm going to try to type in those scores off of while I walk around, have them out on your desk, and I will try to take those scores off of your paper and put them in through the iPad.